Okay, so we are going to just dive right into doing an example of calculating a confidence interval for a population mean when the standard deviation is unknown. And the reason why we're diving right into it is because it's essentially the same process as calculating confidence interval when the standard deviation was known and we use the normal distribution. We're just going to go through the same process, but tweak it a little bit because now the population standard deviation is unknown, and we have to use some different calculator functions because we're using a different distribution. We're using the student's t distribution. So let's look at this one. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population from which you took the data. Okay, and so here's the data. So let's look at our given information. Okay, so you measure sensory rates for 15 subjects. So we know our sample size is 15. Now, if we weren't given this, okay, we could have just counted the number of datums we have here. And let's make sure I got this right. So we got 2, 4, 6, 8, 10, 12, 14, 15. Okay, we got 15 datums here. Use the sample data to construct a 95% confidence interval. So what that means is we have a confidence level of 95% or 0.95. And just like before, this is going to be a two-tailed distribution. So we're going to need our significance level, which will be 5%, because 0.95 plus 0.05 will add up to 1. All right, and because it's two-tailed, we want to take the significance level and divide it by 2. So half of 0.05 is 0.025. All right, let's see what else we got. All right, so use the sample data to construct a 95% confidence interval for the mean sensory rate for the population, assumed normal, from which you took the data. And that's all we got. So notice something that's missing. Um, the population standard deviation is unknown. We have no idea what that is. In the previous section, we were told, assume it's this, or it was found out earlier to be that. But now it's unknown. We don't know what it is. So, this is kind of telling us that we need to use the student's t distribution now. Some other things that are telling us we need to use it besides that is also that our sample size is less than 30. We've got a really small sample size. Um, yeah, so, but this is the primary one here. All right, so what we need is we're constructing a confidence interval. So we need the sample mean and we need the margin of error. Now, we have neither right off the bat. So what we need to do is maybe first look at calculating the mean. So how do we get that? Well, we can get that by using the calculator. So we can use the Texas Instruments or NumWorks. And I took the liberty of putting the data into both calculators. So in the Texas Instruments, we just go to the list editor and put all of the data, all 15 datums into list 1. And for the NumWorks calculator, you want to go to the Statistics app and put all the values into the column V1. All right. Now, in order to get the sample mean, to get X bar on the numerics calculator, just move up to the tabs and go to the stats tab. Click OK. And then down the left-hand column, you want to look for sample mean, X bar. Sample mean, X bar. So that's 8.227. Okay. Yeah. So I'm going to put 8.227 there. Okay. So we know by using both calculators. Oh, I need to flip back over because I realize I didn't do Texas Instruments here. Okay, so now that we have the values in list one, we want to run one variable stats. So hit the stat button, calc, menu. The first one is one variable stats. We want to do one variable stats on list one. Go to calculate. And you can see we have 8.226, the same answer we had with the numworks calculator there. All right. Okay. Now, the other thing that we're going to need, actually, we're going to need this standard deviation. So we need the sample standard deviation as a substitute for not knowing what the population standard deviation is. So that's going to be 1.672. So let's go ahead and write that down. 1.672, and it just keeps going. Let me see here on the numworks calculator. Sample standard deviation. That's here right down below. All right. Now, let's see here. Let's go back to the problem. So now we've got our sample mean. What we need now to calculate is our margin of error. And so in order to calculate the margin of error, we need to use the margin of error equation, which is going to be a T alpha 2 score. Now it's not sigma, it's just going to be the sample standard deviation divided by the square root of n. All right. The sample standard deviation we just got. Okay, we had to calculate that. Sample size we know is 15, so we're good there. We just need to calculate this T alpha 2 score. So just like we did before, we can also draw this student's T distribution. Just make it symmetrical, something like that. And it's going to be two-tailed. So this is going to be our positive T critical score, and this is our negative T critical score. The confidence level is equal to 0.95, and that's this area here between the two critical values. The area in the tails, that's alpha over 2, that's 0.025. That's this area. And this area out here is the other part of the significance level. Right? Okay, so what we need to do is use an inverse distribution function to convert this area into that critical value here on the number line. And for convenience, we're going to calculate the positive version of this. Well, it looks like if we use just the native Texas Instruments calculator, it's going to give us the negative T score because it calculates the area from the left. So just realize we'll get a negative value there. The area is going to be 0.025. All right, degrees of freedom. So I should have calculated that earlier. That's going to be n minus 1, which is 15 minus 1. So degrees of freedom will be 14. Let me make that a little bit better. 14. All right. And with the numworks, degrees of freedom is 14. We want the area on the right with an area of 0.025. So let's look and see what our T critical value is going to be. All right. All right, so let's go here and we'll go to the distribution functions, use inverse T, an area of 0.025 with 14 degrees of freedom. Hit paste. Okay, so we're going to use 2.145. But on the numworks, let's do that there too. So I'll go to home and we want to go to the distributions app, go down to students T. We want 14 degrees of freedom. Area to the right, want the third option. And we want an area of 0.025. So it just gives us a positive value, but this looks about right. So 2.145, that's what we got with the Texas Instruments calculator. Same value there. All right. So now we just need to calculate this. All right. So let's see here. So in order to keep our values as high as possible, let's take this t-score and I want to make it positive. So I'm going to multiply this by -1. Okay, that'll make it positive, and I'm going to store this in the letter T. So store, and then hit alpha, and then 4. That'll give us a capital T, and hit enter. All right, that's stored there. I want to do the same thing here. So shift, and then X to the Y key that has this right-facing orange arrow. And I want to put that in letter T as well. So that's going to be shift alpha 6. There we go. All right, so that's our value of T. Now we just need the sample standard deviation and then the square root of n, which is going to be the square root of 15. Now I should have practiced this, but I didn't. Let's see if I can refer to that S value. Let me show you where that can be found. Memory serves. So we want to take T, and we're going to multiply that by the sample standard deviation that we calculated in one variable stats. So we're going to hit this variables button, and let's go to statistics. There it is, number 3. So this is going to use the most recent sample standard deviation we just calculated, maybe with one variable stats. Okay, and you can see it's got the mean there too, and n. So maybe we'll use that. So I'm going to click OK, enter. So there, put it in. I'm going to divide that by the square root. And I think instead of typing 15, which would be faster, but I'm going to put n. Then I'll hit right arrow once, and then right parentheses. All right, so I have less of an intuitive feel here to do this with the numworks calculator, but I'm going to give it a try. So let's go to calculation, and I want to put the letter T in there. So let me hit shift alpha T parentheses. Now I want to put the standard deviation. So let me see what happens if I hit this variable button. Um, let's see. Okay, that's not it. Let me go to lists. No, that's not it. I want to define a new variable. And that's really my only two options here. Those are left over from a previous session. Okay, I know there's a way to do this. Let me look at toolbox. And let's go to nope, that's not what I want. I'm not gonna have what I want either. Um, all right. Well, instead of wasting time trying to find that right now, I really think it should be there. Okay, I got an idea. Let me see here. I got an idea. Okay, let's go back to the statistics app. Let's go down to the sample standard deviation. And let me select this S. I could probably select that value too, but let me see if I can do Shift copy. And let me go back here. Let me hit Shift paste. Nope, didn't work. Thought maybe that would work. Okay, well, I know there's got to be a way to do it. But for now, what I'm going to do is I'm just going to grab this number and I'm going to copy it and then come back out to here and I'm going to paste it and then put divide by the square root. And this time I'm just going to type in 15 and then hit right a couple times and then parentheses and execute. And let's do it over here. Okay, so we're getting the same answer of 0.926, 0.926. So our error is equal to 0.926. So that means our confidence interval of x bar plus and minus e is going to be equal to 8.227 plus and minus 0.926. Now we can check this answer by using the t-interval function. So let's go to the Texas Instruments. And if we go to stat, go over to tests, and scroll down to not z-interval. Now we're going to do t-interval because we're doing a student's t distribution. We want to input data. Okay, list one with a confidence level. I think that was 95%. So I'm going to put 0.95 and hit calculate. Okay, those values look right. So that would be the interval in that notation, let's see our data, 0.95 there. If we go to the numworks calculator and we go home, we want the inference app. Go to intervals. We want one mean, but we want a t-interval now. And we want to use a data set, and it's going to be this one, V1N1. Okay, so we'll hit down. Okay, we want a confidence level of 0.95, and we want to hit next. So it wasn't really intuitive at first, where next was, right? It looks like there was nothing here at the bottom of the screen. So just remember, you do have to scroll down all the way to the bottom so you can hit next. Okay, it gives you the sample mean, the sample standard deviation, the sample size, the critical value, 2.145, and scroll down to next. And here we go, 8.227 plus and minus 0.926. And it gives us also the interval in this format with a lower bound and an upper bound. And you can see the upper bound here and the lower bound here. It's the same. All right. So you can use these interval functions on either calculator to check your answer. Okay, this answer is correct. All right. So that concludes this example. Let me know if you have any questions.